Hi everyone, I'm Fabian Yan, and today we're going to investigate the conservation of momentum and how this can be applied to a real-life situation. First, we have to understand what is momentum. Momentum refers to the quantity of motion that one object has. It is given a symbol of p. For example, a sports team that is on the move has momentum. By definition, momentum is equal to mass times velocity. So now we know what is momentum, but what is law of momentum conservation and in what area can we apply this law? Well, let's take a look at the following statement. For a collision occurring between object 1 and object 2 in an isolated system, the total momentum of the two objects before the collision is equal to the total momentum of the two objects after the collision. That is, the momentum lost by object 1 is equal to the momentum gained by object 2. Notice that it is important to mention that the system is isolated. The principle behind it is essentially Newton's third law. Let's consider a collision between two objects, object 1 and 2. When the two objects collide, the forces acting between the two objects have the same magnitude but opposite direction. Therefore, we can express this statement in equation below. F1 equals negative F2. In addition, the forces act on the two objects for an amount of time. And if we look at the individual object, the time that the force acts upon object 1 is equal to the force acts upon object 2. This can be expressed as T1 equals T2. As I have mentioned, the forces act between the two objects are equal and with opposite directions, and the times for the forces to act on the objects are the same. This means that the impulses experienced by two objects also have same magnitude but different directions. We already know that the impulse experienced by an object is equal to the change in momentum of the object. Thus, it can be reasonably inferred that the objects also experience equal and opposite momentum changes, which can be stated as m1 times delta v1 equals to negative m2 times delta v2. Now, we can look at the simple experiment that demonstrates this concept. There are two cards with equal masses and both of them have a spring at their end. When pushing the two cards towards the center, the strings will be compressed and therefore gain energy. Let go of the cards. They will travel at opposite directions. Now push the two cards, make the strings compressed, and use a thread to fix the cards to prevent the cards from releasing. There are two blocks behind each card at the same distance, which is 2 measures away from the card. Now, use a lighter to burn the thread. We can see that the cards travel in opposite directions and hit the blocks at the same time. Since the distance between the card and the block is the same, we can then say that they travel at the same speed. So, initially, the system has a momentum of 0 because nothing in the system is moving. The final system, however, has a momentum of m times v plus m times negative v, since the left card is moving at the opposite direction, which is also equal to 0. In the other experiment, we add an iron block that has the same mass as the card. Notice that this time the distance between the block and the card is not the same. There are 2 measures between the card without the iron block and the block, whereas there's only 1 measure between the card with the iron block and the block. Burn the thread and we can see that the 2 cards also hit the block at the same time. Initially, the system has a momentum of 0. However, this time, after the interaction, the momentum is expressed as 2mv plus m times negative 2v, and it is equal to 0 as well. After watching the experiment, you may be wondering why the momentum are equal to 0. Well, don't forget what I've mentioned. Momentum in an isolated system is conserved. In the calculations for the first situation, since the two cards are moving in opposite directions, one of the cards is moving with positive velocity and the other one is moving with negative velocity. Remember that velocity is a vector. By simply adding them, we can see that the momentum of the system after the interaction is zero as well. In the second situation, the card with 2m has positive velocity and the card with m has a negative velocity that is 2 times than the velocity of the 2m card has. By adding them together, we get 0. By the law of momentum conservation, we know that the momentum before the interaction between two objects is the same after the interaction. When the masses of two objects are different, the velocity of the two objects will change and vice versa. This is the law of momentum conservation, and thanks for watching the video.